Hello everyone, this is Lubaba Tasnia ID 18101292, and in today's project I have made a simple line following robot. I did the part of robot's body making. In this robot I used 3 distance sensors, 4 wheels or 4 hinge joints. In the first project we have used the same robot, but for now I have changed its color. So here in the robot, let's pause and zoom in a little bit. Here in the robot, we can see these are my 3 distance sensors and 4 hinge joints. Under robot part, here we can see one solid, which is basically the camera, which I haven't used. Then we can see 3 distance sensor right, distance sensor mid, and distance sensor left. And each distance sensor must be pointing downwards. The rays must be pointing downwards. Under view, optional rendering, and show distance sensor ray, we can see the razor pointing downwards. So the name of the distance sensor must be the same we use in the code. And here are my 4 hinge joints. Under each hinge joint, we can see the position axis anchor values. Here we can see the second hinge joint, third hinge joint, and fourth hinge joint. But for the distance sensor, the translation value of each sensor is different, but the rotation and scale values are same. Here we can see the rotation and scale values the same for the left one. So next is DF body shape. The body shape, here I used a rectangular body shape for my robot. You can use any shape of your preferences. So these are all from my part. Thank you.
Assalamu alaikum. I'm Diana and my ID is 18101229. I will show how we made the track of our robot. So we have to go to this website called Autodesk Tinkercad and create a new design. So we have to choose this option called Scribble and draw a track. Now we have to make the height of this track as low as possible. We make it 0. We will change the color to black. Now we will export it as OBJ file. So we have downloaded it and now we have to extract it. Now we have to import the Tinkercad file in our Webot. So we have to go in import 3D model, choose the Tinkercad file, and here is our Tinkercad track. We have to change the translation and rotation. We have to change the scale. So here is our track.
I'm HM Irfantasin. My ID is 18101515. I'll be talking about the coding part of our project. So this is the code. Our robot will work. At first, we have to integrate it with the Webot. As we can see, we have some variables in this code. First of all, I imported the robot library here, then created an instance robot. We used timestamp 32 millisecond. We have used 4 wheels in our robot, 2 on the left and 2 on the right. We initialize these wheels here. Here also the device name needs to be the same as we declared the wheel's name in robot. Here this will give us the value of the IR sensor, which we will be able to see at the console. In this part of the code I have initialized the sensor. Here the device name needs to be the same as we declared in the sensor's name in the Webot. In this segment of the code we will be processing the sensor data. We are creating a while loop that will run infinite time. Then we get the distance sensor value of 3 sensors. We need to calibrate it from the sensor data. It depends on the reading of the sensor. As we can see from the sensor data, in the part we use the threshold value 300. When the middle of the sensor is active, it is giving us a reading of around more than 300. That is why we made the threshold value 300. If the sensor is not on the line, then it gives a value less than 300. But if it's on the line, it gives a value more than 300. Depending on the value, we may get some error values. We will align the robot in correct path. For that, we put the error in P and calculate the integration part. Just by adding error with the integration value from the previous part, we put them in the I. In the same way, we calculate the differential part just by subtracting the previous error from the current error. Then, for balancing the robot, we calculate the balance function. We multiply PID with the corresponding constant value KP, KI, KD. After that, we set in the wheel speed for every wheel depending on the balancing value and the maximum speed value. After that, we run the robot. This is how we can say our robot is staying on the black line. The way this works is during making a left turn, the left sensor and the middle sensor will give a high reading, where the right sensor will give a low reading. The difference causes the left motor to stop temporarily and the right motor to speed up temporarily. This causes the bot to make a left turn, and for right turn it's vice versa. This is how we know the robot understands when to go straight, when to go left and right. That's all. Thank you.